Hello dear students, welcome to our learning program Ready to Run, produced by Rwanda Education Board or REB in partnership with UNICEF and Inspire, Educate and Empower Rwanda. I'm Teacher Jen and I teach Senior 6 Geography. As usual, let's start by sharing an important message from the Ministry of Health. It says, we should respect the measures of hygiene such as hand washing, social distancing, no handshaking, and others to fight against the spread of coronavirus. Thank you. Dear students, before we start, let's have a review of what we learned in the previous lesson. Think of the key elements we focused on. Great! Last time, we looked at the rocks, their characteristics, and their classification. We saw that rocks are divided into three types that are igneous, sedimentary, and metamorphic rocks. We have also seen that their types, their characteristics, and their classification vary according to their mode of formation, where they were formed, and their constituent, among others. Today, we are learning composition and properties of rocks. I want you to be able to describe it, but also to discuss the advantages and disadvantages of rocks on landscape and on human activities. Our lesson is on page 152 to 161 of the student book. Friends, rocks are composed of physical and chemical elements. Can you use your previous knowledge to describe at least one property of rocks? Use your previous knowledge and describe at least one property of rocks. Great! All rocks are composed of minerals. Composition refers to both the types of minerals within a rock and the overall chemical makeup of the rock. What are the minerals that compose each type of rock? We are going to see it. I would tell you the type of rock and the forming minerals. Starting with sedimentary rocks, their forming minerals are silicate, clay, dolomite, gypsum, anhydrite, hematite, and limonite. These are the minerals forming the sedimentary rocks. The second, the metamorphic rocks, are composed of quartz, muscovite, sillimanite, andalusite, kyanite, garnet, sericite, and stororite. These are the minerals composing the metamorphic rocks. The last one, igneous rocks or magmatic rocks, are formed by quartz, feldspars, micas, pyroxene, amphibolite, and olivine. The rocks have physical and chemical properties. When you look at physical properties of rocks, a physical property of a rock can be intensive. We look at the hardness and softness of rocks, or can be extensive. This is about volume, total mass, and weight. Rocks, whether igneous, sedimentary, or metamorphic, are subjected to powerful stress or pressure by tectonic forces and the weight of overlying rocks. The physical properties of rocks determine their behavior and respective deformations when a rock is subject to stress such as faulting, or warping, and the resulting landscape deformation. When we talk of stress, stress refers to the forces that constantly push and pull or twist the Earth's crust. There are three types of stress: tension or stretching, compression or shortening, and shear or twisting or tearing. We also have strain. Strain is how rocks respond to the stress, whether by stretching, shortening, or shearing. Again, when you talk of surface expressions, these are the expressions we'll be using within this session. When you talk of surface expressions, this refers to the structure of landforms resulting from the stress, depending on whether the rock is brittle or hard, or ductile or pliable. Surface expressions can be folding, meaning bending, or faulting, breaking, and brittle rocks breaks, while ductile rocks like clay bend or flow. We call it ductile deformation. Welcome back. We have just seen the physical properties of rocks. We have seen that a rock can be intensive or extensive. We have also learned that folding, faulting, and warping play a major role in determining the physical properties of rocks. Now, we are going to continue with chemical properties. Regarding the chemical properties of rocks, let's start by sedimentary rocks. All water falling onto the earth as rain and running over the earth's surface carries minerals in solution. These minerals may precipitate by direct evaporation of water, chemical interaction, or by the release of pressure where underground water reaches the surface. Sedimentary rocks formed as chemical precipitate include halite, gypsum, silicate, limestone, and dolomite. When you look at metamorphic rocks, metamorphism involves the alteration of existing rocks either by excessive heat and pressure or through the chemical action of fluids. This alteration can cause chemical changes or structure modification on the minerals making up the rocks. Metamorphism process results in the creation of new minerals by the substitution, removal, or addition of chemical ions. Metamorphism may consist of three minerals: kyanite, andesite, and sillimanite. These are the aluminium silicates having the same chemical formula but different crystal structures and physical properties. The last is the igneous rocks or magmatic rocks. The major indicator of the chemical classification of igneous rocks are the amount of silica, and igneous rocks with a high proportion of silica exceeding 65 are said to be acidic or basic. For example, the granite found on extensive part of Muhanga district in Rwanda. Where the amount of silica is very low, less than 45%, the rocks are said to be ultramafic or ultrabasic. Rocks having intermediate silica content comprise between 65% and 45% are said to be mafic or basic rocks. Igneous rocks are classified according to their forming minerals. Mineral groups include basic minerals, mafic, and ultramafic mineral, and some of these rocks form underneath the earth's crust and are known as intrusive magmatic rocks, whereas others form from the volcanic lava that reaches the earth's surface, forming extrusive volcanic rocks. Remember, we saw it last time. Briefly, water, heat, and pressure are among the major agents of chemical properties of rocks. Thank you. As you have said it before, rocks have an impact on landscape and on human activities. Friends, I want you to think of the advantages of rocks on humans. What are the advantages of rocks on humans? Thank you. As you have said it before, rocks have an impact on landscape and on humans. I want you to think of advantages of rocks on landscape. Some rocks are more resistant to weathering and others are less resistant. This difference in rock resistance provides various landscapes such as alteration or elevated topographies, this means hills and mountains, and depressions like valleys and low-lying areas which are sometimes drained. Gravel and sand, being among products of the rock weathering, make beautiful landscape at some location of the earth which may attract tourists. Also, weathering of rocks provides different types of soils including sand, silt, and clay which are useful at various points of agriculture. Some rocks store or purify water and act as water source to rivers. These are some of the advantages of rocks on the landscape. Again, I want you to think of the importance of rocks on human activities. What is the importance of rocks on human activities? All right. Rocks have a wide variety of uses. Many of them are used as building materials of houses and infrastructure such as roads and railways. For example, sedimentary rocks like coal formed from decayed plants and animals is mainly used in power plants to make electricity in some countries. Salt, as a sedimentary rock, also is an essential nutrient for humans and most animals. It is also used in winter on roads to control the accumulation of snow and ice. This happens especially in countries of Europe, America, where they have these seasons of winter or summer. Yes. Also, limestone is used mainly in the manufacture of cement, in the production of lime, and so on. Sandstone, also a sedimentary rock, is used for construction. When we look at metamorphic rocks, quartz is very hard and used in building houses, railway, and roads, while marble is beautiful for statues and decorative items such as vases. Clay are most utilized minerals not only as soil that grow plants for food and garment, but also a great range of applications including oil absorbents, pottery, wastewater treatment, paints, and so on. When you look at igneous rocks, for example, granite is used in both building constructions. We have these stones for house foundation and bridges, but also for statues. Some varieties of floor tiles for houses are also manufactured from granite. We have also peridotite, which is an igneous rock and used in jewelry. Basalt also is used as flooring, countertops, and in construction projects. Friends, even if rocks have an importance on landscape formation and on human activities, it also has some disadvantages. Now, I want you to think of some of these disadvantages of rocks on landscape. Excellent. Hard and resistant rocks hinder the penetration of plant roots, hence limiting the weathering process or hindering the growth of vegetation. Rocks forming minerals have different colors. The difference in colors make minerals to absorb differently the heat. Dark-colored minerals absorb much heat during daytimes and therefore expands, causing the cracking and fragmentation of rocks. Rocks forming minerals have different colors. The difference in colors make minerals to absorb differently the heat. Dark-colored minerals absorb much heat during daytimes and therefore expands, causing the cracking and fragmentation of rocks. Dear students, what do you think are the disadvantages of rocks on human activities? Great! Rocks can be an issue on human activities. For example, the sun can blow, rocks can roll, risking injury and death to people. Also, light-colored rocks reflect sunlight and increase the temperature along the plants during daytime. Some environments, such as sand rocks, are not suitable for human settlements because of lack of water and soils. Again, some rocks may reflect landscape with steep slopes where humans' activities such as agriculture or settlement cannot be possible. To summarize our lesson, what have we learned today? All right. As conclusion, we have learned the physical properties of rocks. A rock can be intensive in terms of hardness and softness, or extensive in terms of volume, total mass, and weight. We have also learned that folding, faulting, and warping play major roles in determining the physical properties of rocks. We have also seen chemical properties of rocks. We have seen that water, heat, and pressure are among major agents of chemical properties of rocks. Finally, we have learned that rocks play a big role in the formation of landscape, all depending on their characteristics, chemical, and physical composition. We have seen that some rock features serve as touristic attractions. We have also seen that rocks are important to humans as they are used for different purposes such as constructions, decoration, source of energy, for example coal, nutrients, for example salt, and so on. However, we have learned that some rocks are a threat to the landscape and to humans. Some can act as a barrier to the growth of vegetation because they hinder the penetration of roots. Others are not suitable for human settlement. All this will bring us to our conclusion that humanity should try to live in harmony with the natural resources to preserve our mother planet. Thank you. To end our lesson, as usual, we have a homework. Take your pens and notebooks and note it down. It says, using relevant examples in your local environment of objects made from different rocks, discuss the economic importance of rocks. I repeat, using relevant examples in your local environment of objects made from different rocks, discuss the economic importance of rocks. Thank you for your attention. See you for the next lesson. I'm Teacher Jen. Bye.